So, good morning, everybody, and welcome to today's weather briefing. I'm very happy to see almost 30 of you attending online today, and I hope we will have a very interesting discussion over the next 45 minutes. So, my name is Zanita Vodnets, and I'm from Latvia, and I will be your moderator today for a very, very special briefing event. And there are two reasons for it being special. And the first of them is that we are doing this briefing from Iceland, where the annual NOMEC course for the Nordic countries takes place. And this year there are 26 participants attending from 9 countries and also joining the briefing. So today we have a big number of online attendees plus a classroom full of NOMEC participants. So, okay, so that's about us, but please tell us, where are you? So could you please put a star on the map to show? Great, so most of you are from Europe. All of you are from Europe. So this might be a very interesting event for you, because the second reason of this briefing of being special is that today we are going to have a whole European event, and that is 5 presenters giving briefings from different parts of Europe. So at first, Tater from Iceland will give a briefing for the Northwestern Europe. Then we will switch to Larissa from Russia, that will tell us more about the weather in the northeastern part of Europe. Unfortunately, we don't have Barbara from Poland attending, so we will not have the briefing for the Central Europe. But then Milica from Bosnia and Herzegovina will tell us more about the severe floods that they are having in Balkans at the time. And at the end, Carla from Portugal will give a briefing for the Southwestern Europe. So enough of the introduction, and I will now give the floor to Tater from Iceland for a short briefing of the weather conditions over the northwestern part of Europe.
Yes, hello, this is Tater speaking. Well, the weather around Iceland these days it's pretty quiet, so I'm gonna give you talk about some interesting things from last winter. And I'm going to start with a pretty modest picture, which everybody likes. You can always look at these things and find something interesting. This picture was taken 2 days ago on Tuesday, and it shows that the sun was shining on us then here at the NOMEC course, as it has up until now. And we see that what I'm going to talk about is the snow cover in northeast Iceland. And so I'm going to switch to the next slide. Yep. And I'm going to switch to from the true color image that we saw earlier to the RGB 367 mixture, which shows snow and ice in a red color. And we see that in northeast Iceland there's still a lot of snow in the higher ground, as I'm pointing out to you, but in the lower ground there's no snow. And when discussing the situation with the people in the northeast, they say that, well, there's unusually high amounts of snow in the mountains, but there was unusually little snow in the lower ground. So we wanted to investigate this further, and the reason for this can be understood when we think about the period from Christmas up until early March. For 2.5 months we had prevailing northeasterly winds with precipitation in the northeast part. And this map here shows you what was happening then. The lines on this map, they denote the mean sea level pressure, the average for 10 days in early February, from the 5th to the 15th of February. But the color denotes the deviation of this 10-day mean from the 30-year average for February. And the average is taken from 1981 to 2010. And this early February period, this was the period with the highest frequency of or strongest cyclones. There was a frequent colder outbreak during this 2.5-month period from Canada, meeting warmer air further south, and cyclogenesis happening typically in this area, and the lows moving across the Atlantic. And now I have a question for you. Where on this map is the greatest pressure anomaly? If you could put a star on it. Okay, that's good. Thank you. We see that it's a huge anomaly for these 10 days. The pressure, the average for the 10 days, the pressure was up to 37 hectopascals below the 30-year average. And we see that what this means for Iceland. We have northeasterly winds with lots of precipitation, but the flow was what we in the forecasting room sometimes call backwards flow, meaning that these were not cold northerly winds. They were warm enough so that the precipitation in the lowland was rain, but there was lots of snow in the mountains above, let's say, 300 or 400 meters. So that this is the reason for what the people in the Northeast say. And I have one more slide to show you. I'm going to show you some NWP data. This is data from the Harmony weather model that we run 4 times a day, each day at the Icelandic Met Office at 2.5 resolution, 2.5 kilometer resolution, sorry. And in August each year, we zero out all the snow, except on the glaciers, of course, and then the model throughout the winter accumulates the snow. And then we take exported data at the end of April and at the end of winter. And what this map here shows you is the difference between last winter and the winter before that. So areas with gray, white, purple, and blue tones, they are areas with more snow in last winter, and these are the higher elevation areas. Here I'm marking the mountains in the East Fjords. But on the other hand, the brownish tones, they show areas with more snow in 2013, 2012, 2013. So the lower areas had less snow this last winter. So this feeling of the people in the Northeast shows up clearly in our snow and WP simulations. Thank you for listening. This is all I had.
So thank you, Teitur. Very interesting slides. And now I would like to give the floor to Larissa from Russia. So please go on.
Hello to everybody. My name is Larissa. I'm from Aviamed Telecom, that is the aviation department of Roshydromet, Russian Federal Weather Service. And I'm going to talk about the northeast part of Europe, the weather briefing. The northeast part of Europe includes the European part of Russian territory. And firstly, I'd like to ask you all about the eastern borders of Europe. Not any politics, just only geography. You can use your drawing tools to indicate me where do you think the eastern border of Europe is and where I need to stop talking about the weather in Russia. According to the other geographical European borders, southern, western and northern, everything is clear. There are the coasts of Mediterranean Sea, Atlantic and Arctic Ocean. And what about eastern border of Europe? Yes, you're right. The border lies along the Urals, the mountains that separate Europe and Asian part, and Caspian Sea. So that is the territory that I will be talking about. It includes the European part of territory, and I will talk a little bit about Ukraine, Belarus, and a little bit about Baltic countries. The main macro-synoptic feature in the northeast last few days are the high pressure system over the center of the European part of Russia and the cut lows in the north over Baltic Sea and south over Black Sea. The belt of southeastern flow stretches from the south to north along the periphery of Russian anticyclone, bringing a hot and dry air to north. The most anomaly high temperature was yesterday observed in Moscow and St. Petersburg, bringing new temperature records about 33 degrees Celsius, that is 10-12 Celsius higher than usual. The anticyclone over West Russia keeps its strength with no forward motion is expected. In low troposphere, the extensive convergence zone remains along the eastern fringe of Russian high. It extends from Ukraine to Estonia and further northeast towards St. Petersburg and Arkhangelsk. Low pressure system with a heavy stationary front contributes for well-organized multi- and supercells. Heavy rains, large hail over 8-10 centimeters observed, and severe winds gusts over even a few tornado events under the mesoscale convective vortex occurred the few last days in Ukraine, Belarus, Baltic countries and the southwest of Russia, along the slowly propagating cold front. Meanwhile, in the southeast part of Russian high over Urals and North Kazakhstan, and a very long and sharp trough, the northern inflow brings cold air, morning freezing and even snow. That is an anomaly for the late May for these territories. Yes, even in Russia, May is usually the warm month without snow. Looking at meteor alarm map issued by Roshydromet for tomorrow, and for looking at today EUMeTsat satellite images, could you guess what is that orange areas be dangerous for tomorrow? Again, you can use your drawing tools to write or to draw some signs. Is it any other suggestions? What is about thunderstorms, high temperature? Yes, yes. Okay. The answer is the large mesoscale convective system over northwest and southwest borders of Russia now is dissolving and transforming into the numerous smaller scale mid-level vortices. Daytime activity consists of isolated thunderstorms, and during the evening rapid upscale growth into large cluster is forecasted. Strong multicells may produce wind gusts and extensive precipitation. So most alarms for thunderstorms and wind gusts. You can see it in the left and bottom pictures. Meanwhile, in the central part of European territory of Russia, most alarms are for the anomaly high temperature. It is in the top picture. Looking to the whole Russian alarm map for the next 5 days, we can see weakening clusters of storms over northwest and southwest of European territory, and the snow events with severe wind gusts over the north, with the north inflow over the southwest Siberian part. So that is the end of my small weather briefing. Any questions?
So thank you, Larissa. So it seems that in the northeastern part of Europe there's quite of a summery weather going on. Very nice to go back to Riga and Latvia afterwards. So now we will move on to Milica, that will tell us more about extreme weather, but from the southeastern part of Europe, and more about the severe floods they are experiencing there at the moment. So please go ahead.
Hello everybody, I'm Milica Đorđević from Bosnia and Herzegovina. I work in Republic Hydrometeorological Service of Republic of Srpska. Last week we had terrible floods. Just to show you where is it on this map. Okay, I will use a star, sorry. I'm here, this is the part that my service covers, so I will talk about data from this part. But this is whole Balkan here on this map, and you can see area with the heavy floods. Unfortunately, the latest number said it's 33 dead people in this event, and 16 of them are from our country. I will start and I will go a little back and start on 13 May in evening. We have intrusion of a low from north, a little colder air, as you can see here. And in that moment, on 13 in the evening till the 14 in the morning, we already had heavy floods and heavy rain in south and central part of the country. In the most of this situation, the cyclone has its usual path. It's going over Bosnia, going to Serbia, and in most of the cases it go further to the southeast in Greece and Turkey. But this time something different happened. It moved back a little bit. Okay, this is one radar images of that day. So I will just go to the next day. It's 15. You can see the center of cyclone here. It was very strong and it stayed constantly over the Balkans, over the Serbia and over the Bosnia. In that moment we have in some areas more than 100 liters of rain. This is also one of the radar images, and in this area here and here in Serbia was 3 cities that was most affected with floods and unfortunately with most dead people. And finally, on 16, the cyclone started to be a little more weaker, but the rain in that moment went a little more on the west and then hit west part of our country, even the Croatia. So what was very interesting, we have this for 3 days with a lot of rain. Rain in these days with some region fell more than a 3-month average in our area. So I would like to ask you a question. Can you see on this picture, can you see this? Okay, I will use this one. This on air mass images, this pink, is it? I'm not sure. Is it a PV advection or is it jet stream? So you can see it on everyday satellite images. So I find it very impressive. Oh, this is also one of the radar images on the final day, and now finally on 17 in the midday the rain finally stopped. What happened in those couple of days? I will show you now. This is the amount of the precipitation in only 3 days. In this area here, you can find it to be 100 to 160 millimeters, and the average in this area is around 70-80. And this area on the east and the southeast that was most affected, here there were some places with 220 millimeters of rain in only 3 days. This city here was totally flooded, and unfortunately even our meteorological station went under the water, so we don't have data. We only measure up to 100 millimeters for only 1 day, and after that this river that goes through this area totally break down all the dam and flood the whole city. And after that, after 3 days, Sava, that's going in the north part and going to Serbia, start to raise, and unfortunately all the area over the Sava had a big floods. In that day, even the Croatia had floods, and Serbia also had floods additional from this smaller river, from Sava river also. This is precipitation in April. This is maybe the reason why this flood was so severe. A month before this, in April, we have 3 weeks with constant rain, and also we have maximum precipitation in some area here on the north. For instance, Banja Luka have absolutely maximum ever, so we had more than 200 liters in this area, and our April average is something like around 80-90 millimeters. So combined with that, also with the precipitation of 3rd and 4th May, and now we have in some area more than 500 liters of rain. So that caused a big flood. This is just one picture. I didn't want to show to you all of them because they're very stressful. A lot of them you can find them on the web. You can see how river, that Bosna River in Doboj, look like really like tsunami. In just couple of hours, it raised more than 5 meters high. This is something that NASA published a couple of days ago. This is floods from the satellite image. This is now Sava River. Here. This is that city Doboj that was totally flooded, but it was flooded by this river here, Bosna. You can see here what's going on when Bosna started to go into Sava. This city here also, Bijeljina, it was also, they have a big flood because of 2 reasons. In the first day, this river Drina caused the flood, and then 2 days after that, when all this water went directly into Sava, Sava also had flooded here, also flooded here in Belgrade. Now they still have problems with that. So this is pretty amazing. In normal situation, Sava looked like this in the area, just one tiny line, not like this. And this is unfortunately the picture of our meteorological station in Doboj. And this picture took 4 days after the floods. Now water was even lower than it was, and as our colleague told us, the water was somewhere up to here. And you know how high this is. This is around 2.5 meters of water. So that's it for me.
So thank you, Milica. Looks like you are having a very tough time there in Balkans. So we now move on to Carla from the southwestern part of Europe. So the floor is yours.
Okay, good morning everyone. So this is me speaking from my office in Lisbon. So I'm starting with this air mass RGB for today at 6 UTC with mean sea level pressure to highlight some features. So we have this deep trough that is almost stationary since the 19th of May. That is bringing a very cold air from the higher latitudes towards our continental Portugal. So we had a very sharp drop in the air temperatures that reached on some places in the north 26 degrees Celsius on Sunday, on the 18th of May. And on the next day, they dropped to 11 degrees Celsius. So a very sharp drop in air temperatures of around 16 degrees Celsius. And this cold air that is being brought from the north is in opposition with this southwesterly flow that is bringing warm air into the north. There are also some features here. We have some PV anomalies here in these reddish colors here, and a bit weaker here. So some intrusion of stratospheric air. And over the Atlantic, we have a large ridge that is giving us fair weather over the Atlantic islands. The next slide shows the day microphysics RGB for today at 7 UTC. This is a quite useful product for severe convection. Today I will not focus on this since we don't have that features over continental Portugal, but I will focus on the water particles, cloud water particles. So I have a question for you, focusing on this area over the Atlantic. I put these two boxes here, and I would like to ask you, where do you think it is more probable to have precipitating clouds? So I ask you to use the yellow stars. So where do you think we should have water particles more big enough to precipitate? Okay, I see you are almost everyone is giving the right answer. This was a simple question to have. Okay, you already given the physical explanation for this, so you are right. So when we have bigger water particles, they will be less reflective in the 3-9 channel, so contributing less to the green beam of the RGB. So, and this gives us this dark pink color for precipitating clouds. And the last feature I would like to highlight is this area over here, very thin cloud, that it is actually a dust cloud that is coming from the North Africa and moving with the flow, with the southwesterly flow into the into South France. So maybe you will have some mud rain, and of course here it's also obvious you have here some mountain clouds. So I think that's all from the southwestern Europe. Thank you very much.
Thank you, Carla. A very interesting presentation and a very useful presentation since explaining the day microphysical RGB. It's probably not used that often. And as I already told you, we are now presenting from Nomek in Iceland. And since we have this course for the Nordic countries, we also have some very high-level specialists around here. So now I would like to introduce to you Phil Chadwick from Canada, who will explain you something more about water vapor imagery of today.
Something strange just happened on the screen, so we'll just talk for a little bit. The water vapor image that we're about to see is composed of shapes and patterns, lines and swirls, and each one of those is like a fingerprint on the atmosphere. And if we examine them, we can deduce exactly what the atmosphere is doing. We need an image to look at to really see that. But one thing I think we're going to see is that every time you have a big trough of low pressure, inside that trough of low pressure are a lot of vorticity maximums. And here we go. We now have a water vapor image up, and the water vapor image is three-dimensional. If you see something, and I'm just going to get a symbol here I can move around. It's a different screen right now, but we'll get there. If you see something that is white, that surface is cold and very high in the atmosphere. If you see something that is dark, that is very warm and very low in the atmosphere. So if you think that high is cold and dark is low, then you have a three-dimensional view of the top 1 millimeter water vapor in the atmosphere. So it's like an isentropic surface. And if you see something, yeah, I can't move a mouse around a point where I'm looking at. That's a bit unfortunate. Nothing I can do, eh? Okay, so if you look at the southerly flow as a warm conveyor belt over Europe, that flow rises as it heads northward until you get into the convection and the deformation zones crossing Norway and Sweden and all the thunderstorms that produce the flooding rains. And if we could look farther to the east, you would see the large anticyclone that's blocking this whole pattern. So we call that the Ring of Fire conceptual model, and that's why you have all the thunderstorms on the north-south line through Europe. Now, if we look, now I can. Ah, good. I like to draw. If you know me, I like to draw, and there we go. Okay, so now it's very exciting. So you see the warm conveyor belt headed northward, and then hits the far north deformation zone and peels off to the east. And it's rising as it goes north. Now, if you look over Iceland, see that high, cold white surfaces, and as it plunges southward, it's getting lower and darker in the atmosphere. So this whole area I'm about to circle is all composed of vorticity maximums and backward S-shaped deformation zones. Now, if you see a swirl here, that's a vorticity maximum, and what is going to happen with that with time? Well, we can use the water vapor to forecast, and typically when a low gets off the coast of Newfoundland, it's going to develop. And what we'll be looking for would be a tropospheric fold, darkening in the water vapor image coming off Labrador. And as that happens, that low moves and develops. And that could be the weather for Iceland on Saturday. So you can use the water vapor not only as a diagnostic tool, what's happening right now, but using conceptual models, you can deduce what's going to happen tomorrow and the next day. And it's totally independent of numerical weather guidance, and to have a clear, self-briefed assessment of what the numerical atmosphere should look like. And if the two are different, the real atmosphere is your friend, and that's the one that's going to actually happen. All these interesting little swirls that you see, they all reveal something about what the atmosphere is doing. And with a little bit of practice, you can look at these swirls and accurately place vorticity maximums and vorticity minimums, infer differential vorticity advection and ascent and wind shear. And if I can leave you with one idea, the atmosphere is very three-dimensional. The motions in it are three-dimensional, and the motions that you're most interested in are those that are going to favor development of your cyclones. And you can do that independent of NWP. So have fun with this and draw and color, and thank you very much for listening to me. NOMEC is a wonderful course, and I encourage you all to participate.
Thank you, Phil. Okay, I don't see any questions, so we can slowly wrap this up. So you saw what is the weather like around Europe. So if you could choose a place to do the forecast for today, where would that be? Can you please put a star on the map? So which would be the best place to do a forecast for today? Of course, Iceland. Yes, the Baltic countries. Very nice. So some of the people noticed that the weather over the Balkans is quite sunny now, and of course the sunniest places are also the most pleasant, both from a forecaster's point of view and also for going on a holiday. So, by the way, do you know which are in general the sunniest places in Europe in the summer? Please put a star as well. Make a guess. Okay, of course, most of you go for the southern part of Europe. Okay, some pick Russia as well. Ireland. Okay. So let's see how things really are. So here you see the mean shortwave radiation at the surface in the summer season over a long period, so from 1990 to 2005. And this is measured by the EUMeTrain instrument aboard the Meteosat satellites. So, of course, as you see, the most sunny places are found in the southern part of Europe, but not as much in Spain and Portugal, but more in Greece, here in the southeastern part. The not so pleasant areas are the northwestern part of Europe and Scandinavia. I would not say that Ireland is so sunny as it could be, but I would like to use the opportunity to point out the Baltic states. Because if you compare them to what you see over the Central Europe, it seems that in the Baltic states the summers are in general more sunny. So this is just some info for you to reconsider your holiday plans. Okay, I'm just kidding. But if you're interested in such kind of an information about the climatological background of Europe, I would like to announce that a satellite-based climate atlas will be released soon, and it will also contain parameters connected with the clouds and solar radiation, daylight intensity, and surface albedo. So stay tuned if you are interested, because this atlas will be released sometime in July. And with this sunny note, I would like to wrap up today's briefing. Thank you all for joining, and I'm looking forward to meeting you on the next briefing that will be done by Lillian from Austria. And the briefing will be held on June 17 at the same place, of course, and at the same time, that is 9 UTC. So thank you all again, and bye.